Now that we have the engineering model complete, this is as it goes on the aircraft or vehicle. We want to create a manufacturing model and add additional features that may change the shape of the laminate or add excess material. So we don't want to, modify this engineering model directly. We want to make a copy of it. So in order to do that, we use the Composites collaboration and use prepare for synchronization. Once that's done, we then can generate the manufacturing stacking. So what you'll notice is that the stacking here is called engineering, and when we generate the manufacturing stacking, it will copy everything across just like this and generate a manufacturing stacking. So this is a linked model, so if anything ever changes in engineering, we can update the manufacturing. So now that we have the manufacturing model, let's go ahead and add some manufacturing type features. So one of those is that the original green surface, which is the engineering surface, is not the same as the tool surface. In this case, we need to account for some spring back. So I'm going to use a function called skin swapping and basically take all my plies and project them. It notices that the green surface is the OML surface and project those to the tool surface. You'll notice all the ply boundaries morph themselves down into the tool surface. If I center my tree, you'll see that I've added to ply 10 a skin swap feature, including all the others, and then I have a skin swap feature in the tree. Also, what I'm going to do is add some material access. So again, I'm going to choose my ply group and pick an engineering edge, which is this inner edge, and then a manufacturing edge, and add additional material on top of the plies. So notice how the plies have grown larger out towards the side of the surface more. And I've added that material access feature. Now let's do some producibility and flattening. Let's test the flattening on, just say, for example, ply 1. So I'll do a producibility for hand layup. Up comes a panel. I'll do a preview. And what you'll see is a mesh appear, and depending on the algorithm, whether it's like tape or biaxial, it's going to run the fibers out in a circular fashion until it hits the side of the ply. And notice that the yellow is shearing, and that's because of these limit and worn angles. So everything in blue is between 0 and 12 degrees shear. 12, 25 is yellow, and then you'd have red if it was higher. It shows you where the bridging and wrinkling is going to occur. We can also play this back so you can see it occurring in real time. If we do choose a indication point, we can also drag the seed point around, and you can see the preview of the flat pattern. Let's just take geometrical center and accept that. Now what I'll do is I like that producibility, so I'm going to copy it and paste it down through the other plies and then run it. Finally, what I'm going to do is unfold these plies. So we're going to do our flattening. And the location point is going to be the pattern. And we have our flat patterns.